Hello, my friends, and welcome back to our online digital. Hello, my friends, and welcome back to our online digital classroom. I'm really excited to speak and share with you new ways we can engage our learners in the modern science classroom. So this week, we are going to take a look and continue our learning journey into the fundamentals of science. In other previous topics, we learned a variety of different skill sets, such as how do we leverage our students' assets to make them more efficient learners and connect them to the material, utilizing topics such as sense making. We also conversed about the scientific method and its role in science and its flexibility. So this week, we are going to take a look more on a topic dealing with that of the model. So right here, I've actually got one of my favorite hobbies, and that is taking a look at maps, especially old historical maps. In fact, one of my hobbies is to collect these maps and be able to save them for future generations. Because these maps are loaded with lots of great information that both scientists and non-scientists can utilize to communicate the spatial component of navigating the natural and physical world. Now, what does spatial mean? Spatial is just the relationship between the individual, the context of a region, and locations. So this map is a topographic map. This is the topographic map that is supposed to represent Tioga County of Pennsylvania and its relationship to that of the other nearby counties. And so what I was looking at is that I wanted to learn more about the region, changes in elevation. And that's what the topographic map is designed to do, is to show a record, scientific data being visualized right here into a model. And this is really great because I can take a look at this map and look at the relationship between various towns in a connection to areas of elevation or where the high points are. When I take a look at this map right here, I can find areas where it's at least 2,100 feet above sea level. And so that would be a really great way to communicate the characteristics of the mountainous region to our learners. Explain to them where areas that are high versus areas that are closer to sea level can be found, and build that connection, root them into that of the scientific data, and be able to use this as a model to communicate. Now, earlier I mentioned this map was published in 1903. It is now 2024. So our learners have a different perspective on how a map is seen. They probably take a look at maps on their parents' mobile phones, but this truly is also how mapping can be done. And some of the details found in these older maps don't translate as well into a digital map. And so that'd be a great way to connect to the learner, take a look at the phenomena, and ask ourselves, what can maps show us? Now, also, what we're going to be taking a look at is how do we blend scientific technology in and confirm that the phenomena we find in these maps truly is occurring. And we can do that, again, with modeling. I've actually got this model right here. And this is a model that was constructed utilizing satellite imagery. Nowadays, we move away from topographic maps. We still produce them, but technology has started to supersede that, and we can go and fly a satellite over a given area. So I'll pretend my hand is the satellite. We'll fly it over. As it's flying over, it's sending down light, and that light reflects off of the surfaces. The faster that light beam returns to the satellite, it's an area of high elevation. The slower it takes, it's an area of low elevation. Same principle as maybe sonar. Well, this is really good because then we can represent it in another type of map or a model. Each one of these colors represents areas of low elevation going into red, which will be representing high elevation. And so we can actually take this topographic mapping data and convert it into a model we can study in the classroom. What I like to do when I do this in my public outreach is we'll make these colored maps and then take corresponding colored Legos, building blocks, and build this from a 2D model into a 3D one as the learners are stacking these different blocks. And so that's really what our goal for this week is, be able to share with you another way where we can go and find data. You will go and collect topographic map data. In fact, I've actually got an open educational resource for you to access and find maps similar like these and build your own library for your classroom of digital maps. Then we are going to learn on how to make these maps, utilizing some of that data you collected, and then try our hand at building a map made from a satellite. I believe the data that you'll be working with for that map was actually collected by investigating our nearest planet, Mars. I think that's pretty cool because that also can be segued into further explanations with our learners that anything that has occurred on our planet Earth may actually occur out in space. If you have any questions about this week's content, please reach out. You can get a hold of me during my open office hours using video chat. You can send me an email or just swing by my office.